All right, so today we're going to look at systems of equations. So we're going to be graphing lines today and then looking at a solution. And we learned about graphing lines already. All right, so number one, we're going to graph the equation y equals x plus 2 to the right right here on the coordinate plane. So what is our slope and y-intercept of the equation? Yeah, slope is 1 and the y-intercept is 2. Okay, so let's go ahead and plot that. And then just draw a straight line. All right, our slope is -1 and our y-intercept is 8. And we're going to go down 1 over 1. There we go. And then draw a straight line as possible. Make sure you have arrows. Do the two lines intersect? And if so, where? Yes. And where? At point 3, 5. Are we good with that? Questions? Okay. Is the point 35 a solution to the first equation? Y equals x plus 2? Yes. And then we're going to list two ways. Okay. So the first way we can tell is it's a point on the graph, right? You can see it. It is a point on the graph. So the point 35 is a solution to the first equation. It's a point in the graph. And the second reason, what can we do? Love it. You can plug it in. So we have y equals x plus 2. What are we going to substitute y in? 5. What is our x value? 3. 3 plus 2 is 5. Is 5 equal 5?
Yeah.
Yes. Number 4, is the point 35 a solution to the second equation? And of course, very similar reasons why it's on the graph. So one way, when you're given two linear equations, to see if they intersect or their solution is by a point. Okay, so you can either graph it like we just did, right? Or after you graph it, you can see the point of intersection, right? What's our equation? Y equals -x plus 8. What are we substituting y in for? 5. What is x? Good. And then 5 equals 5 again. Are we good? Not bad. Okay. Solutions of equations. An ordered pair is a solution to an equation or satisfies the equation if the point lies on the graphed line, like we saw this above. We can also test a point to see if it is a solution by plugging the x and y values from the ordered pair, like we did with the ordered pair 35, into the equation and see if it makes the equation true. All right, system of equations is a set of more than one equation with the same variables. The point of intersection of two graph equations is the ordered pair that satisfies both equations, or the blank of the system of equations, or the solution. So with your table, I want you to do number 5. Okay, it says what 2 equations are graphed at the right. It's important that the correct equations are written, right? And then what's a solution? And then what does it mean to justify your answer? What do you think I'm looking for? Plugging it in. So our 2 examples right here is how you're going to justify. Okay, so you do like a few minutes and then somebody. All right, number 5. What are the 2 equations that you got? Good. Y equals 1/3 x plus 2. And the second graphed lines equation is y equals 2/3 x. Look at that. One's proportional and one's not. Okay, sorry. Keep going. All right, what is the solution to the system? And it's already graphed, and you can see the point of intersection on the graph. At 6, 4. Good. And then show your work to justify for each equation. So in y equals 1/3 x plus 2, we're just going to substitute in our values for x and y. Good. 4 equals 4. Good. Give them one big clap. 1, 2, 3. All right. Turn it over to the back. We have some practice problems. We're going to graph the equation below to find the solution to the system equations. Then we are going to use the check step to prove that the solution works in both equations. Okay? So we'll do the one that started number 7. And then so what is our slope is what? Negative 1/2. Good. And our y-intercept is 3. Let's just look at that one first. Let's go ahead and graph that one. So our y-intercept is at 3. And then we're going to go down 1 over 2. Down 1 over 2. Or we can go up 1, back 2. And then draw as straight line as possible, because remember we need that point of intersection. And I'm going to do my best to draw a straight line. Amazing. Okay, here we go. All right, I'm going to switch colors for my other line. Okay, y equals 5. Rudy. That means your y value is always what? 5. Okay, so you see how my y value is always 5. Okay, so what does that mean? 0, 5, 1, 5, negative 1, 5. You see the line there? Okay. Okay, so it looks like I need another point right here, right? So I need to go up 1. Are we good? So what is our point of intersection? Negative 4, 5, right? We knew our y value would be 5, right? Okay, and then how are we going to check? We're just going to plug it in. So for the one y equals 5, for the y value, you're just going to substitute in your y value, right? Amazing. Are we good with that one? All right, and then what's our other one? What is our x plus 3? Our y value is 5. Negative 4 plus 3. That's a positive 2 plus 3. You can use a calculator, or of course, if you do it by hand like I did, you can just kind of simplify there. I said that it was equal. It is equal. Okay. Are we good? All right. So with your table, you're going to do the 8, 9, and then number 10 with a real world example. So 8, 9, and 10. I'll see where you're at in 5 minutes, and then we'll have 3 volunteers. Okay.
Let's check our answers. Number 8, the solution is 3, -1. Questions on number 8. Okay. Number 9, the solution is 2, 2. Questions on that one. Okay. Now for number 10, you had to read the situation and then write the correct equation. So graph A is all in orange. Okay, so y equals 3x. And then I did a table. Okay, and then I plotted the orange right here, which is y equals 3 times x. Graph B is y equals 2x plus 2. Questions about the equations. Okay, so here's the graph. Okay, it should have been hours for your x-axis, and then your y-axis is the cost. Are we good with that? And then it's graphed. Do y'all know why I have dashed lines and not a solid white line? Any thoughts on that? Yes, you cannot pay for half an hour, so I did a dashed line. Right, we can't pay for 30 minutes for parking. Okay, it's got to be an hour. Okay, that's good. And then, of course, our solution is 2, 6. And then we had to explain, now that we have meaning behind our equations. Okay. So 2 represents hours and 6 represents what? The cost. Okay, so the garages charge the same amount for 2 hours of parking. Or you could say for 2 hours, both garages charge $6. Okay, so at the 2 hour mark. And that's the only hour. Questions about 8, 9, or 10? Okay,